So we're going to talk about the transition from ratios over to proportions, all right? So we're going to match these up here. So it's asking you right now, so we're kind of taking a step back here, to determine whether or not the following pairs of numbers are proportional or not. You know, there's a whole lot of just yes and no's going on, right? So do you remember yesterday when they were given to you like 3/8 and 6/16, and you just had to put yes or no? The only difference between today is they're going to be written a different way. You still have to tell me yes or no for this for this whole sheet, actually. So the question is going to be yes or no, except instead of giving it to you already in an equation, they're going to give it to you a little differently. And ratios, we know, can be written in a couple different ways. Like 5:3 as 10:2. This means is 2, kind of, doesn't it? So if I were to zoom in on number 1, it says 3:7 as 5:12. Is that a proportion? And you may look at that and say, I have no idea. How can I figure this out? Well, when it's in two fractions, it's probably the easiest way to figure out, right? So we need to just take these and put them as a fraction. So 3:7 as 5:12. And then I'm just going to kind of put a question mark above it because it may be a no. And I don't want to keep that equal sign there if it's a no, right? Because then it's not. So how can I figure this out? Well, we've talked about this. You could use the cross products, which is 5 times 7 is 35, but 3 times 12 is 36. So literally all I just need is a yes or a no for that. So the only difference is we have to set the equations up today, whereas yesterday they were given to us. 5:2 as 20:8. Is this true?
Yes.
Okay. And then what I want to do, if you do decide that it's a yes, is I want to try to cover every single possible way to get to that yes. So, Roger said yes first. Walk us through what way you used.
I did 5 times 4 is 20, 2 times 4 is
Yeah, that's what I usually do. If it's like a pretty cut and dry one, yeah, I mean, that's pretty simple. When the factor between the two numbers is both the same, so I could either multiply this fraction by 4 or divide this fraction by 4. So it's either multiply to get the bigger one or divide to get it smaller. Any other options? Yeah, Nikolai.
the cross thing.
Yeah, the cross thing, the cross products. So I'm going to multiply the diagonals, and 2 times 20 is 40, and 8 times 5 is also 40, so that's a big old yes. Got it? Okay. So pretty simple, same concept. Let's just do 4:7 as 12:21. What do you think is the easiest way to do this one? Times 3, or divided by 3. Either way, it's a yes, right? Okay, can you tell just by looking at this next one without even setting it up? How do you know? Because 10 is half of 20, and 9 is half of 18. So 10, 20ths, 9, 18ths. Here's another method that we didn't talk about yesterday. If you are good at reducing, yes, could you just simplify both fractions and see if they simplify to the same thing?
Wouldn't that be no? Because 10 does not go into 9.
Oh, great. Brings up a good question, guys. He says that he looked at it and kind of thought that it was going to be a no because you can't put 9 into 10 like you could put 4 into 12 or 5 into 4. This was a no only because the cross products didn't equal. Yeah, not because this didn't equal. So if you did 10 times 18, you get 180. And if you do 20 times 9. Or, as I was just saying, everybody listen up. Could you reduce 10 20ths down to a half? And what does 9 18ths reduce down to? So, we have another way. If both of the fractions you're looking at reduce down to the same, yes, a half and half. You got it. So, think about what I just said to help you, to help you decide if that's a yes or a no. This fraction is already in simplest form. This one is not. What would this one be if I simplified it and cut it in half? It would equal 6/7. And does 6/7 equal 5/6? No. So are you like, I'm equipping you with like so many different ways to figure out yeses and nos. Hopefully one of them is sinking in. So 3 is to 5, as 15 is to 25. Yes, because if I divide this by 5 and divide this by 5, 25 divided by 5, and so on. So this is a yes. Okay. We flew through that, and I kind of thought we would, but it's number 7 and 8 that I want you to take a look at. All right, guys. 7 and 8 is asking you the exact same thing it asked you up here, except instead of giving it to you like this, they're giving you some big old fancy story to read. I want you to read it. So here's the deal with this. When you split things, so somebody has 30 jelly beans and 6 gumballs, and somebody has 5 jelly beans and 1 gumball. Do they both have the same proportion of jelly beans to gumballs? Yes. So something to think about here, and that doesn't really apply to this problem, but I just want to know if they have the same proportion of gumballs. If we're splitting things up, like, have you ever had like a cookie and then you have to split it in your family and everybody argues over who gets the biggest piece? Like if you have to share something with your brother or sister, it's always like, they get the bigger piece or whatever. So you know the rule in our house is, if we have one thing and there's 2 kids that need to split it, one kid splits it, the other kid gets to choose what piece they want. Think about that. Why is that the case? If you were the splitter, what would you do? Create them as equal as possible, because if you know you got one piece bigger, that your brother or sister is taking that bigger piece. So the question is, do they have the same proportion? I know they don't have the same amount, like he has obviously more, but just kind of taking a peek at that. So are you ready? We're going to use these 2 problems to set up how we do our next worksheet, James. Okay. So here's where your colored pencils and highlighters are going to come out. First thing you're going to do is make 3 fraction bars and set them all equal to each other. This is how every one of your problems today is going to start. And then I want you to use, it doesn't matter which color, I'll have blue here. I want you to, a ratio is comparing 2 different amounts of things, right? What 2 things am I comparing? Yes, jelly beans to gumballs. And then you know what I'm going to do? I'm going to highlight that first fraction in blue because what I want to write there are the words jelly beans and gumballs. Yeah, just a bit. So jelly beans to gumballs, and that goes there. Every single proportion you're going to work on, yeah, you have to write the words. It helps. Okay? So now what I'm going to do next is just circle all the numbers that I am dealing with. 30, 6, 5, and 1. And so now I have, bless you, 4 numbers, and I have 4 open spots. Can I just throw them down wherever I want? No, I have to put them in a certain place, right? So here's the deal. We're going to let this first fraction right here represent David, meaning this one. Ran out of room. And we're going to let this fraction right here, the second one, represent Kevin. Okay? And so now it's kind of like Battleship, right? David's jelly beans goes here. David's gumballs go here. Got it? So if David has 30 jelly beans and 6 gumballs, and Kevin has 5 jelly beans and 1 gumball, I know they don't have the same amount, but is the proportion of jelly beans to gumballs the same? Yes. Use one of your theories or options that you did up here. Cross products, reduce, multiply or divide. Does this work? Yes. Okay? So yes, they have the same proportion of jelly beans to gumballs. I combined them. That would be good, huh? Okay, so let's try another one, and I'm going to give you a different sheet. 3 fraction bars. Yeah. This one's a little tricky. I really want you to read this whole problem. You got somebody who works full-time and somebody who works part-time. Now, how would you feel if you were a full-time worker and somebody worked half as much as you did but got the same amount of vacation time? I would be kind of mad if I was the full-time worker. If I was the part-time worker, I'd be like, oh yeah. Shouldn't the amount that you work be proportional to the amount of vacation you get? Right? So, that's what this problem is asking you. Is it proportional to each other? Is it fair? So, in blue, what am I comparing? Well, be careful, because if we say weeks, the amount that they work to the amount of vacation that they get. So this is the number of hours or days that they work versus the vacation time that they get. Now be very careful with this. And I guess if we had to put each fraction as something, this fraction could be the full-time, and this could be the part-time. If that helps, you'd put that there. So, now I want to circle 50 and 2 and 22 and 3. Except this is one where I'm going to highlight any other important information. So, how many weeks does the full-time employee work? 50. They only get 2 weeks off. And how many weeks does the part-time work? 22. Now, I did this separate for a minute because I want you to look at this. They earn 2 weeks of vacation. The part-time people earn 3 days of vacation. So what number should I put right here? 2?
14.
Yes. Very good. Did you hear that? So, do you see a 14 anywhere in the problem, though? No, that was kind of a little side note that you had to know to do. So, is it okay to put 3 here? Yeah. So, this kind of looks like a messy one. 3 doesn't go into 14, 22 doesn't go into 50. I suppose I could reduce this down, but then I would still have different denominators. So, your best bet might just be to do your cross products. So, 50 times 3 is 150, and 22 times 14 is not 150. It's 308. So, is it proportional? No. Who does it seem like it's more fair to? The full-time person. Why do you think?
Because if you were to double the part-time person,
Yeah.
they would only get 6 days of vacation.
Yes. Great. So that's another way he did it. Guess what? He didn't even need to do that. He said, well, what if I just doubled the part-time hours and said instead of 22 hours, they worked 44? Then if every time your hours worked, your vacation days doubled, then that would be 6, but it's 14, and that's another common sense way of doing that, okay? Good.